Jai Hind to all of you. I am Dr. Gaurav Saxena, Associate Professor in EC Department. So today I have discussed the Unit 5 in antenna and wave propagation, KEC 603. The executive code is KEC 603 and the topic is sky wave propagation, which is very important in AKTU exam as well as the UT exam. This is the first topic is what is the sky wave propagation and what is the benefits of sky wave propagation and what is the structure of D layer, E layer, ionosphere layer, F1 layer, F2 layers. So in sky wave propagation, we have to be covered the what is the frequency range of sky wave propagation, which one is 2 to 30 megahertz, and there is a we have to be I just started what is the layer in ionosphere layer where the sky wave is to be transmitted and reflected back to the earth. So first this is the earth and this is the troposphere layer. So first layer in ionosphere layer is D layer. So and second one is E layer, F1 layer and F2 layer. So these layer is to be defined by the what is the electron density. So if I can say the electron density per centimeter cube. So electron density per centimeter cube we have to be defined by F2 layer, and electron density is different from F2 layer to F1 layer, and the electron density of E layer differ with the F1 layer and electron density differ from the D layer. So ionosphere layer is to be started from 50 to 400 kilometers. So the what is the minimum range of ionosphere layer, which one is 50 kilometer to, and the maximum range is 400 kilometer from the earth's surface. So if I can say so if a sky wave occurs, so most of the waves is to be designed by or reflected by D layer, E layer, F1 layer and F2 layers. So what is the electron density? So out of that, this is the G region. So this is G region. So so each layer is to be having a some electron density from, this is the minimum electron density, this is the maximum electron density. So in this layer between them, so the electron density are same, or we can say from day D layer, E layer, F1 layer and F2 layer are present, but in the night phenomena, see so D layer is absent because of sun is not is to be involved and the electrons are to be square. Then D layer is to be merged in E layer and F1 layer is to be merged in F2 layer. So during the daytime, D layer, E layer, F1 layer and F2 layer are present, but in the night time D layer is absent. That means the E layer is to be D layer is to be merged in E layer and the F1 layer is to be merged in the F2 layer. So what is the express or refractive index? So what is the refractive index? So this is first topic which has to be I have to be just explained it. So what is the refractive index in terms of the frequency? So I just this is the formula. If refractive index is the what is the refractive index of any layer which have to be passed. So that means the refractive index n, which one is equal to the under root 1 minus 81 n upon f square. And what is the n? N is the electron density of that particular layer where the sky wave is to be reflected back from the earth. And f is the n is the electron density in per centimeter cube or per meter cube, and f is the transmitted frequency in megahertz, because the range of sky wave is lies from the 2 to 30 megahertz or 3 to 30 megahertz. That means the range of frequency which has to be transmitted by earth. So you have to put it, and we put it the frequency and the electron density here. So if you put f in megahertz, if I can say a megahertz, that means the 10 to the power 6 hertz, and then you put the electron density in per meter cube. So you have to be converted what is the electron density which are given, and we have to be converted in, and we find the what is the refractive index of that particular layer by using the formula n is equal to 1 minus under root 1 minus 81 n upon f square. So what is the refractive index formula in terms of the permittivity? So we also know that the permittivity air is equal to under root epsilon upon epsilon naught, where epsilon naught is the relative permittivity of that particular layer. So this is the refraction formula, which I also calculated by the Snell law, as n is equal to sin I upon sin r. And in terms of the permittivity, which one is equal to the under root epsilon upon epsilon naught, and which is equal to the under root 1 minus 81 n upon f square. So what is the structure of ionosphere layer? So this is the ionosphere layer, which is very important. This is very important, which has to be asked in AKTU and semester examination in KEC 603. What is the meaning of this? So N1, N2, N3, N4, N5, N6. So whole of the ionosphere is to be divided into the 6 medium or 6 channels. That means that according to the electron density. So if I move to from the Earth D layer to E layer or F1 layer to F2 layer, so the electron density is to be increases. So if we move from the Earth, so electron density is to be increases. So that means, and the refractive index is to be decreases. So that means that if by using the Snell law, we know that if N1 is here, N2 is here, where N1 is greater than N2 according to the Snell law. So this is the incident wave. So reflected wave is to be just away from the perpendicular. So that means if the refractive index, if I can say, so this, if we transmitted a sky wave from the Earth, so it is to be bent to that particular layer and reflected back to the receiver side. So some important phenomena or definition we have to be designed in that particular unit. First one is what is the critical frequency. So what is critical frequency? So that particular frequency, that maximum frequency which has to be penetrate that particular medium and reflected back in a Earth. So this is the critical frequency of that particular layer. If I can say 2 or 3, if I can say this is the D layer and this is the E layer. So this is Earth. So this is the transmitter and this is the receiver. So what is the minimum cutoff frequency which has to be penetrate that particular medium and graze down and is to be reflected back that particular medium and reflected back to the Earth? That particular frequency is called the critical frequency. So this is the maximum frequency which has to be reflected back and that particular medium. If I this is the maximum frequency. If I can say for D layer, this one is 10 megahertz. Critical frequency 10 megahertz. If I transmitted a 9 megahertz frequency, so that means if we transmitted a 9 megahertz frequency, so that means this is less than critical frequency, because the critical frequency is 10 megahertz. Suppose if the critical frequency is 10 megahertz for D layer, so critical frequency is more than the transmitted frequency. That means this transmitted wave is not to be entered in D layer. So this is the critical frequency. What is the significance behind that? So what is the maximum frequency you have to be transmitted that particular medium which has to be penetrate and reflected back to the Earth? So this is the critical frequency, and this is the formula we have to be derived in terms of electron density. So critical frequency is the 9 under root n maximum. So how we calculate it? So we know that what is the refractive index? Refractive index is sin I upon sin r, which one is under root 1 minus 81 n upon f ka whole square. So 81 n upon f का square or 9 under root n maximum का whole square. So according to the definition of critical frequency, So if I is equal to 0, what is the meaning of I? I is the incident angle, which is, this is I. If I is equal to 0 degree, so we transmitted a sky wave perpendicular. So that means in this case I is equal to 0. So I is equal to 0. That means in that time n is equal to maximum electron density. So this is the condition for critical frequency, to find the critical frequency. So we put it, this condition, in that particular equation. So n is equal to sine I, that means the sine 0 upon sine r, which one is equal to the under root 1 minus 81 n max upon fc ka whole square, because in at that time frequency which is equal to the critical frequency, where the electron density is maximum, that particular frequency is called the critical frequency. So we put it, that means 0 is equal to under root 1 minus 81 n max upon fc square. So we to remove the square root, so we square on both sides. So 0 is equal to 1 minus 81 n max upon fc square. So fc square is equal to the 81 n max. So fc is equal to 9 under root n max. So this is very important formula to find the critical frequency of any ionosphere layer. If I can say D layer having electron density is 19 into 10 raised to power 18 atoms per centimeter cube. So you find the critical frequency. This is the n max. So that means you find the what is the critical frequency. So you have to put it, this n max, in per meter cube in that particular formula, and we find the critical frequency in hertz. So n max is the per centimeter cube per cube meter. If you put the formula, if you put the maximum electron density in that particular formula, so you put the value of n max in per meter cube. So we easily find the what is the critical frequency of D layer, E layer, F1 layer, F2 layer, and any layer if maximum electron density of that particular layer, if I if given, if I know, then we easily find the what is the critical frequency of that particular medium. So next is maximum usable frequency. So what is the meaning of this? This is the minimum frequency of that particular area we have to be transmitted or reflected back of that particular in the receiver side. So that particular frequency is called the maximum usable frequency. Suppose this is D layer having a cutoff frequency is 10 megahertz. So that means if I transmitted a 10 megahertz frequency here, so it just grazed down and reflected back by the receiver side. So if I increase the frequency 12 megahertz, so they penetrate more in that particular layer and receive in the receiver side. But if we increase is 20 megahertz, so that means if I can say this is the minimum frequency which has to be transmitted by that particular region. So that frequency, if I can say this is the 20 megahertz frequency for that, but suppose 20 megahertz frequency of that particular band or that particular region is to be maximum, is the minimum frequency which has to be reflected back that particular region. So this type of frequency is called the maximum usable frequency of that particular region. But if I increase 21 megahertz, that means which is penetrate that particular region or which has to be going to another region. If I can say D, this one is E, so which penetrate the another region which is not to be reflected back that particular region. So this minimum frequency is called the maximum usual frequency of that particular region. So if we transmitted any wave, sky wave in a D layer, so we know that what is the critical frequency of that particular region, what is the maximum usual frequency. If I can say, if the critical frequency of that particular region is 10 megahertz and maximum usable frequency of that particular region is 30 megahertz. So for D layer, if I can say for D layer, if we transmit or if we communicate between the D layers, so we transmitted a frequency in between them, 10 to 30 megahertz. So this is the frequency span of that particular layer where we establish a communication between the transmitter and receiver. So this is the how we calculate the what is the formula of maximum visible frequency. So we easily calculate. So this is the refractive index formula, n is equal to sin I upon sin r, which is equal to under root 1 minus 81 n max upon f muff whole square. In this case, so the angle of r, that means the incident angle and the reflective angle, for maximum visible frequency the angle of r should be 90 degrees. So that means if the reflected angle is 90 degree, so we can say this is the maximum visible frequency, and if the incident angle is 0 degree, so if we transmitted a frequency of incident angle is 0 degree, so we can say this is a critical frequency. So if we put it, r is equal to 90, sin 90 is 1. So if we square in on the both sides, so sin square I is equal to 1 minus 81 n max upon fc is equal to 81 n max n maximum. So if we put it, 1 minus fc square upon f muff square is equal to this, and we put it f muff is equal to fc. So if we put it, so what is the f muff? F muff is equal to fc sec theta I. So this is a very important formula. If the refractive index is given, or we can say if the electron density are given, so we easily calculate the critical frequency, and if incident angle of that particular ray is to be given that, so we easily calculate the f muff by using the formula f muff is equal to fc sec theta I. So finally we have to be conclude that what is the f muff? F muff is equal to fc sec theta I. So always you remember that for a particular layer, so f muff is always greater than the critical frequency. So this is the some formula or some pictorial representation of the ionosphere layer, where the layer 1, layer 2, if we transmitted a layer in ionosphere layer, upper layer and lower layer. So this is the what is third important definition is the virtual height. What is virtual height? If we transmitted a sky wave, then this sky wave is to be reflected back to the earth by using the Snell law. So this is the particular layer where the we saw that where your sky wave is to be reflected back, but we know that we unaware that if I can say this is the projected part. What is the projected part? Projected part is there. So we assume that the layer is to be reflected back from this side. So what is the virtual height? So virtual height is the height where the sky wave is to be reflected back in a projected path, but this is not a projected path. This is the actual path where the due to the some changes in the sky, so the ionosphere layer is to be shifted back, or the electron density is shifted back. So we can say, so this happen in the before the actual path. So we can say, so this is the actual height and this is the virtual height. So what is the height? Virtual height. This is the where the this is the distance from the Earth's surface to the where the projected path of sky wave is to be occurs. So this height is to be the virtual height, but always virtual height is greater than actual height. Actual height where the your sky wave really is to be reflected back to the Earth, and what is the projected path of that particular sky wave? That is the projected path. So what is the height of where the this sky wave is to be reflected back from the Earth? So this distance is to be virtual height. So what is skip distance? So skip distance is very important. it is the shortest distance from the transmitter measured along the surface of the earth at which skywave of fixed frequency will be returned to the earth. So in this case we have to see that this is transmitter and this is receiver. So if I transmitted a particular frequency at different incident angle I1, I2, I3, I4. So in that, where the first sky wave is to be made, so that particular distance is called the escape distance. So what is the escape distance? So in that particular antenna, this is a dead zone where no sky wave occurs. So this distance is to be measured from transmitter to the receiver, where the first sky wave is to be reflected back to the earth. That particular distance is called the escape distance. So in this case, this is the first sky wave. So transmitter to the receiver distance, this is the escape distance, where another sky wave which has to be made here, but this is not a escape distance, where the first sky wave, or we can say वो shortest distance where the transmitter to the receiver, where the first sky wave is to be made. So we can say that particular distance is called the escape distance. So escape distance we have to be calculated. So next is what is the day-night phenomena for in the case of escape distance. So we see that in the escape distance daytime, the escape distance is d escape day. In the night time, the d escape is increases. Due to the night time, the upper layer is to be rare medium. So upper layer is to be not to be involved, because the sunlight is not to be on the earth surface. So that means, so the medium is rare. So this particular sky wave, if we compare that in the daytime and the night time, so during the daytime, because the medium is dense, so this sky wave to be reflected back here, and the escape distance where the first sky wave is made. So this distance is to be d escape during the daytime, but in the night time the medium is rare. So this escape distance is to be, so this sky wave is to be penetrate more vertically in the ionosphere layer, and they reflected back here. So in that particular region, the escape distance is to be increases. So we judge if we hear the FM in night, so we can say, which is very clear, because the escape distance is to be increases. So the power we have to be consumed, or power that particular in that particular medium is which is more than the daytime. So this is a very important day and night phenomena of escape distance. So what is the relation between the escape distance and maximum usual frequency? So if the flat earth we have to be calculated, if we assume that the earth is flat, this is the transmitter and this is the receiver, and this is the d escape distance, and this is 90 degree, this is 90 degree. So that means this is d by 2 distance, this is d by 2 distance, and this is the virtual height, or we can say height of the where the sky wave is to be reflected back, or actual height distance. This is the incident angle, this is the reflected angle. So we have to be calculated mu is equal to sin I upon sin r, where the sin r is equal to 90 degree. That means the f is equal to f muff. By the definition, mu is equal to 1 minus 81 n maximum upon f muff whole square. So we easily calculated sin I, sin 90 is 1, sin I is equal to this, sin I is equal to, if we put that, what is the critical frequency? We know that critical frequency 9 under root n maximum. So fc square, which is equal to the 81 9 n maximum. So we put it, what is the 81 n maximum, which is fc square. So we put it fc square, this is f muff square by the definition, because the angle of r, or we can say sin r is equal to 90 degrees. So we put it and we square on the both sides. So sine square I is equal to 1 minus fc square upon f muff square, because the because the under root is to be vanish out, and sine square I is equal to 1 minus fc square upon f muff square. 1 minus sine square I is equal to fc square upon f muff square, and cos square I is equal to this, cos I is equal to this. And we, how we calculate it, because cos I, by using the this, you know that cos I is equal to dy 2 dy 2 upon under root dy 2 का whole square plus h square. So we easily calculate cos I is equal to this, and we put it f muff upon fc is equal to under root 1 plus dy 2h का whole square. So where d is equal to skip distance and h is the height from the earth surface where the sky wave is to be reflected back. Thank you.